Welcome to Pantech Learning. In this session, we are going to talk about the driving scenario designer app. And before we get into the topic, first, this is a day 8 of masterclass series on autonomous vehicle. Today topic is going to discuss about the driving scenario app. So we are going to create a driving scenarios by using that driving scenario designer app in Matlab. So what is the main purpose of this app? So first we should know about the introduction about the app, that means the driving scenario designer app. The main purpose of this app in Matlab is to provide a user-friendly interface for creating and simulating the complex driving scenarios. It allows the users to design the virtual environment which roads, vehicles, pedestrians and other objects, and then simulate the behavior of these elements over the time. And also these driving scenario designer app, it's look like this only. Here you can see this is the app inside the Matlab software, and we are going to create that app. So before we are going to create a scenario, we should know the things. So first, this driving scenario designer app, it serves these several key purposes. So what are the purposes? First, it enables the scene creation. So it enables the users to easily create the driving scenarios by adding the roads or adding the vehicle, adding the pedestrians and adding the other objects like that. So this is particularly useful for testing the autonomous driving algorithm. And it allows for the creation of a diverse and realistic scenarios. So that is what the scenario creation. Next one is the trajectory definition. What is this trajectory definitions? Users can define the trajectories of the vehicle and the other actors within that scenario. This includes like the setting parameters such as the speed, acceleration, or a turning behavior or a yaw angle like that. So these are all the trajectory definitions. Next one, sensor configurations. Mainly this driving scenario designer app, it allows the users to configure the various sensors such as the vision sensor, radar sensor, and specify their properties including the FOV, field of view, and range and resolution. Next, users can simulate the scenario to observe the behavior of the vehicles over the time. So this simulation capability, it enables the testing of control algorithms or sensor fusion algorithms and other components of the autonomous systems. Next one is the data generation. So this app, it can generate the synthetic sensor data including the reductions from the visions and radar sensors. Based on that simulated scenario, this synthetic data can be used for testing and validating the algorithms without need for the real world data. So overall, this driving scenario designer app provides a comprehensive environment for developing and testing the autonomous driving system. It allows users to create and simulate and analyzing the driving scenarios in an efficient manner. So this is what the little introduction about that driving scenario designer app. So today we are going to talk about, we are going to create a scenario. So in this example, we will go through the whole process. So from creating a driving scenario to generating the synthetic sensor data. This synthetic sensor data, it helps us test over the controllers and sensor fusion algorithms without having to hit the actual road. This is the main thing. Today we are going to discuss about these things. So first, what is the procedure to create a scenario? What is the simple procedure to create a scenario? In that app, first we have to add a road. So this feature, it allows you to create the virtual roads within the scenario. You can define the layout and shape and characteristics of the road, such as the curve road or a direct road, like that. So intersections and lanes. So this is the add a road. Next, we have to add a lanes. So lanes means it defines the individual pathway within the road. You can add the multiple lanes to a road that specifying their width or markings and directions. This is what lane. and the barriers. So here you can see this is the lane, and next is the barriers. So barriers means what? Barriers, it's like a objects. So barriers are the objects that placed alongside roads to prevent the vehicles from leaving the road way to separate the lanes. You can add the barriers to enhancing safety or define the specific traffic configurations. Next one, we are going to add our vehicles. So what is a vehicle? This feature, it enables you to place the virtual vehicles within the scenario. You can define the properties such as the size and type and speed and acceleration and behavior of each vehicle. In that add vehicle topic, we are going to add the ego vehicle and second car. So what is the ego vehicle? So ego vehicle in the sense that is a main vehicle. So which vehicle that carries sensors? The ego vehicle, it represents the vehicle of interest that typically the vehicle controlled or observed in a simulation. So it's often the vehicle for which sensors are configured to gather the data. Next one, add a second car. So this allows you to add additional vehicles to the scenario which can interact with the ego vehicles or other objects in the environment. So it helps us to create a realistic traffic scenarios, realistic roadways, realistic driving scenario. So that is why we adding the ego vehicle and cars. Next one, pedestrian. So these pedestrians are the virtual characters that simulate the people walking or moving alongside the roads. You can add these pedestrians to the scenario to simulate the interactions with the vehicles. Next, add a sensor. At last, we are going to add the sensor. So we know sensors are the visual devices that is used by the vehicles to perceive their surroundings. So what's around the vehicle? These include the sensors, camera, radar, lidar. So which is act like the real environment. So they are very crucial for collecting the data and making the decisions in the autonomous vehicle. Next, we are going to add the camera. So we know the cameras are the sensors that capture the visual information about the environment. So they are used for tasks like the detecting the objects, recognizing the traffic signs and monitoring the surroundings. Radars. So next we are going to add the radars. So radars are the sensors that use the radio waves to detect the objects that measure the distance, speed and direction. So they are useful for detecting the object in a poor visibility condition or at a longer ranges. So next one is the lidar. So what is this lidar? We know the lidar is a light detection and ranging. These sensors, they use a laser beams to measure the distance to objects in the environment. They provide the detailed 3D maps of the surroundings. So these features in the driving scenario designer app that allows you to create a detailed virtual environments and populate them with the vehicles. So let's do the demo for this. So I'm going to open the Matlab software here. This is the Matlab software. So to open the app, there are two ways. I will show you that one. It will take a few seconds to open this Matlab software. In this Matlab app, go to this app section. Under this automotive, here you can see the driving scenario. Otherwise, you can directly type this driving scenario designer in the Matlab command window. So to open the app, there are two ways. Directly go to the app. Under this automotive section, here you have the driving scenario designer app. Or else you can directly enter the driving scenario designer in the Matlab command window. So I am going to open under this automotive driving scenario designer app. Once you click that one window will be pop up here. Wait few more seconds. It takes a time. So go back to our slide. So first we have to add the road. So here you can see this is the canvas. So this is the what is it? Scenario canvas. Here only we are going to add the road. So I am going to open the driving scenario designer app. Yeah. So this is the app. Here you can see the designer tab here. First, we have to add a curved road to the scenario canvas. So this is the scenario canvas. Here you can see on the app tools strip, click the add road. So go to add road. So then click one corner of the canvas, extend the road to the opposite corner and double click the canvas to create the road. So I will show you how to make this one. I am going to drag this one to this one. So double click this. Yeah. Our road is look like this only. To make the road curve, so we are going to add the road center. So I am going to add the road center. So before I am going to zoom in this road, I am going to change this width of this road. Wait, I am going to change this width of this road to 10. Here you can see the width of the road is changed. Now I'm going to add the road center here. So to make the road curve, first we should add a road center around which to curve it. So that is why I'm going to add. So right click on this middle of the road and select the road center. So right click on this middle of the road, go to the road center, and in this road center, so then drag the added road center to any one of the corners of the canvas. So I am going to like this. I'm going to like this curved road. I'm going to make this curved road like this. Now I'm going to create the another few elements. So to adjust the road further, you can click and drag any one of the road centers. To create a more complex curve, add a more road centers like this. Now I am going to add the lanes. So by default, the road is a single lane. So and has a no lane, and also it has a no lane markings to make the scenario more realistic. So convert the road into the 2-lane highway. So I am going to do that one. So for that, in the left pane, so in the left plane on the road tab, so under the road tab, expand the lanes section. So I am going to set the number of lanes. I am going to set the number of lanes. First, you should expand this one. I'm going to set the number of lanes. So this one. So this lane width parameter to the 3.6, which is a typical highway lane width. So I'm going to give this enter here. So this is the 4.925 because I'm changing this width. So based on this only, this lane width also will be available. So this is the lane width parameters, that is a 4.925. So which is a typical highway lane width. Here, so the solid line, it making solid line markings on the either edge of the road that indicate the road shoulder. So the yellow double solid line marking in the center, that indicates the road is a two-way road. So if you want to change these settings, if you want to change the lane marking list, so go to this one. Here you can see, go to this lane markings and go to this tab and change this one to the double solid. So there are white solid lane markings on the each side of the road. Here you can see each side of the road, that is a white lane markings that represent the road shoulders, providing a boundary for the vehicles. So meanwhile, the yellow and double solid lane marking in the center, it signifies that the road is a two-way road, indicating that traffic flows in both directions. If you want to change or adjust these lane markings, you can do by using this lane markings under the lanes tab. So now I am going to add the barriers. So to add the barriers along the edges of the curved road. So for that, use the app tools strip or the road context menu. On the app tools strip, go to the actors and go to this Jesse barrier. So move the cursor to the right edge of the road. Move the cursor to the right edge of the road and click to add a barrier along it. So I'm going to click this one, right click this one. Yeah, here you can see the barriers will be added. Now, so here you can see the left plane of this designer app. The barrier tab will be open. So I'm going to add a gap 1 meter between the barrier segments. So I'm going to change this one. I'm going to change the segments. Wait. Now I'm going to change the barrier segment gap. That's 1 meter. I'm going to do that one. So in this gap, it's a segment gap. To add a gap of 1 meter between the barrier segments, change the value of this segment gap. I'm going to change this one. Now I'm going to add the guardrail barrier to the left edge of the road. Using the road context menu, right click on the road and select the add guardrail. So I'm going to select this one, right click on this road. Go to the add guardrail. I'm going to choose the left edge. So we are going to specify the 1 meter gap between the barrier segments. So change this 1 meter under this barrier tab. Add guardrail to the left edge. Yeah, here you can see the guardrail will be changed. So the same way I'm going to do this one only. So go to actor and go to the chassis barrier and select this road. Go to chassis barrier and select the road. I'm going to change the segment gap to 1. Yeah, the same way here also we successfully created that barriers and guardrail. Now we are going to add the vehicle. So by default, the first car that you add to the scenario, that is called ego vehicle. That means which is that main car in the driving scenario. So ego vehicle in the sense, ego vehicle that contains the sensors that detect the lane markings and pedestrians or the other cars in the scenario. Add the ego vehicle and then add a second car for the ego vehicle to detect. So I am going to add the ego vehicle first. So to add the ego vehicle, right click on one end of the road. So I am going to click this one. Right click this one, add a car. Yeah. So from this car, to specify the trajectory of the car, and right click the car and select the add waypoints. Right click the car and add the select waypoints. I'm going to draw the waypoints here. So like this, you are going to create your waypoints of your ego vehicle. So I'm going to create this. Press the enter. So this is the waypoints of your ego vehicle. So this waypoints along the road for the car to pass through. So after you add the last waypoint along the road, press the enter. So the car auto rotates in the direction of the first waypoint. So here you can see. So just I'm going to run this now. Just see what will happen. Here you can see the car is moving through that waypoints. Now you can also right click the path to add the new waypoints. So go to start. So here this is the triangle. This triangle, it indicates the pose of the vehicle. So with origin located at the center of the rear axle of the vehicle. So if you want to adjust your speed of the car, for that I'm going to use the trajectory. So we want to adjust the speed of the car. So if you want to adjust the speed of the car, go to the actors tab and set the constant speed. So what is a constant speed? I am going to change this constant speed to the 15 meter per second. So for more control over the speed of the car, set the velocity between the waypoints. Set the velocity between the waypoints and the waypoints column of the, set the velocity between the waypoints in the column of the waypoints and speed and wait times and yaw angle. So what is this waypoints? So waypoints in a sense is the specific points that along the road where you want to vehicle to pass through. So it's like a checkpoints that the vehicle follows this path only. So by adding or adjusting the waypoints, you can precisely control the route the vehicle takes within the scenario. Next is the speed, that means velocity. So I'm going to change the speed to 15 meter per second. So this column in the table, it allows you to set the velocity of the vehicle at each waypoint. You can specify the different speeds between the waypoints to create the realistic acceleration and deceleration patterns. That means forward and backward for the vehicle. So for example, you might want the vehicle to slow down as it approaches a curve or a stop sign. So next is the wait. So this is the wait. That means wait times. So wait times, it indicate how long the vehicle should pause at each waypoint before continuing to the next one. So this can be useful for simulating the scenarios where vehicles need to wait at some intersections or for pedestrians to cross the road. That is the real meaning of the wait times. And next one is the yaw. So what is this yaw? So this yaw, it refers to the direction of the vehicle at each waypoint. So by adjusting these yaw values, you can control the angle at which the vehicle approaches each waypoint. So that allowing for the for smoother turns like that. So the waypoints and speed and wait times and yaw table, it provides a detailed interface for the customizing the trajectory, speed and behavior of the vehicles in the scenario like that. Now I'm going to add the second car. So for that, now I'm going to add the second car. So for that, add actors and select the car. I'm going to select the car in opposite direction. So just drag the car inside the road. Right click on this, add the waypoints. So I'm going to create the waypoints for this vehicle. This is the way you are going to create your waypoints. So at last waypoint, press the enter. So add a vehicle for the ego vehicles. So this is the add a car. So I'm going to add a second car. So that is the ego vehicle sensors to detect this vehicle. So for that, I'm going to click this add actor, and from this add actor, select the car and leave the speed and other settings of the car. It's unchanged. Now I'm going to run this one. Let's see what will happen. So this car speed is 30 meter per second and this car speed is 15 meter per second. So go to start. Now I'm going to add a pedestrian. So add to this scenario a pedestrian crossing the road. So zoom in on the middle of the road. I'm going to zoom in on the middle of the road. So this is the middle of the road. Here I'm going to add that one. So from this to this. So for that, go to actor and select the pedestrian. I'm going to pedestrian here. So right click this, add the waypoint. Press the enter. So by default, the pedestrian color it matches the lane color. So I'm going to change that pedestrian color to green. So this is the pedestrian color. I'm going to choose the green. So to test the speed of the cars and the pedestrian also, so run the simulation and adjust the actor speeds or other properties as needed by selecting the actors from the left plane of the actors tab. So for example, if the car are colliding with the pedestrians in the sense, in the column of the waypoints, speed and wait times and yaw table, so we have to adjust the speed of the cars or a pedestrian. Alternatively, you can use a wait column of the table. Set a wait time for the cars at the waypoint before the pedestrian crosses the street. So I'm going to do that one. So just see what will happen. So here the car and pedestrian will collide. So I'm going to change that one. So for that, go to this name of the car or select this one. Select this car and go to the wait state. I'm going to change the wait state to 1 second. So wait state to 1 second. So just run the simulation. What will happen? So up to 1 second, our eco vehicle does not move. So by default, the simulation ends when the first actor that completes its trajectory. So I'm going to change this one. So to end the simulation only after all the actors complete their waypoints or complete their trajectory. So for that, I'm going to go to the settings and first actor, change this to lost actors stop and click apply and then OK. Now run the simulation again. Yeah, our ego vehicle will start. So why wait time? So why we change the wait time of the ego vehicle car? So to test the speed of the vehicles and pedestrians and start by running the simulation. You can adjust the speed and other properties like the cars and pedestrian by selecting them from the left plane of the actor's chart. So if you are notice cars colliding with the pedestrian, you can change the speeds, a column of the waypoint speeds and time, wait times and yaw time. So this is the way you are going to avoid that colliding the ego vehicle with that pedestrian. And now I am going to run this simulation once again, final one. So I am going to zoom out this one. So just zoom out. So go back to start and run this simulation once again. So now only our ego vehicle start. So this is the way you are going to creating your driving scenario and adding the actors, adding the cars, adding the other vehicles and pedestrians, and adding the waypoints to your vehicle. So the same way I am going to simulate this one in a 3D display. So what will happen? Wait, see. Go to this one. View simulation in a 3D display. So wait a few seconds. Go back to our simulation again. This is the 3D display. Go to start and run again. So this is the 3D display of our simulation. So now only our car will move. This blue color car is the ego vehicle and orange color car is the other vehicle. So you can change the speed of your pedestrian or your vehicle also. This is the way you are going to create your driving scenario and adding the cars, that means ego vehicle car, and adding the vehicle, adding the waypoints. So this is all about how to create the driving scenario driving scenario in a designer app, driving scenario designer app. So it's like creating a driving scenario. It's like a digital playground for a self-driving cars. That means autonomous car. So we design the virtual roads so here you can see we design this virtual roads. We design this virtual roads with the lanes and complete the markings and intersections like that. So this allows to test and refine the autonomous driving technology by simulating the various scenarios like navigating through traffic or avoiding the obstacles, avoiding the colliding. So that means car and pedestrian, avoiding that colliding. So it helps us to understand how these self-driving cars or autonomous cars make the decisions and improve their ability to safely and efficiently traverse real world environments. So this is all about our today